Hello, I'm Ana Magradze, and me and Nika Dzigvashvili will present you VGA protocol. In this presentation, we will firstly talk about what is the VGA protocol, then where it is used, how it works, and what are the advantages and disadvantages of this protocol, and lastly, what are the alternatives of it. So, VGA stands for a video graphics array or a video graphics adapter. This is a display standard developed by and developed and released by IBM in 1987. The VGA interface is an analog interface. More specifically, a VGA connection usually receives an analog RGB signal from a device, such as video signal you get from a computer, and send this analog video signals to compatible devices. Such devices might be a projector or television connected to your PC with a VGA cable. A VGA cable does not transmit audio signal, so a separate audio connection will be required for this. The original VGAs only supported resolutions of 320 by 200 and 640 by 480 with a refresh rate of 600. Further development of VGA supported much higher resolutions. Regardless of resolution, they are commonly referred to as just VGA. People often call VGA connector D-sub connector, but more correct would be to say that VGA is a 3-row 15-pin D-sub connector. You can see on the picture, it has 15 pins aligned in 3 rows. And the D-sub miniature, or D-sub for short, is a common type of electrical connector used in computers, and the most popular D-sub connection is the VGA. The analog video signal is composed of 5 different components: red, green, blue video signals, and horizontal and vertical sync signals. The red, green, and blue signals represent the image's color information, while the horizontal and vertical sync lines provide the blueprint to construct the image. In addition to the video signal, a VGA cable will also carry identification information from the monitor to the computer, digital display channel, and extended display identification data provide the computer's video card with the information about the monitor's capabilities and supported graphic modes. Here you can see a rectangle with 2 lines on the left and right side, and this is a symbol used to represent the VGA connector on many computers and devices. So what is the usage of VGA connector? VGA connector is VGA. Generally, it's used for connecting the laptops to projectors for presentations, connecting computers to CRT monitors, for connection of DVD players, TVs, and other devices with an analog video interface to computers or laptops with a VGA connector. Also for video games on older generations of consoles, connecting for a Raspberry Pi or Arduino to a monitor or other devices such as with a VGA interface. Also to transport. Also for transport of high resolution images from one computer to another through the network, and also for video editing.
Hello, next we will be discussing how VGA interface works. So first, let's take a look at the important signals. These ones are horizontal and vertical syncs, and we also have a horizontal and vertical position. So first things first, let's take a look at the low-level overview, how the code was organized. So we have a test bench, inside of which is a system on a chip. And here it is hard-coded to draw 32 by 32 white square on the top right-hand side of the display, as you can see at the right side of the screen. So the square must be in orange and the rest of this display must be blue. But also you see here that other than those regular 640 by 480 pixels, you see the additional area around it, which is 800 by 525. So this additional area is used to communicate with the display. So We will take a look at them, what they exactly do. Now back at the code. In order to make this work, we need 25.2 megahertz clock when actually running on the board. This is preferably done via PLL, a phase locked loop, but for the simulation purposes, we will be using 25 megahertz clock, which will just divide the 50 megahertz clock by 2. Looking at the VGA controller, this will have two simple inputs. One will be a clock and the other will be reset. And it will give out the following outputs. So this will be SX and SY, which are the positions on X and the Y axis. We will also have horizontal and vertical sync, and we will also have a draw enable. So this draw enable signal will be used by system on a chip to decide when to send actual pixel data and not everything else. So here are some important information as well. So we will be drawing at 640 by 480, as you have already guessed, and the refresh rate will be 60 Hertz. So that is approximately 16.67 milliseconds. Now let's take a look at the important part of the codes. The HDL code was written in a system Verilog. So here we can see some important signals. On the left, you can see a draw enable, which becomes 1 if we are in the actual drawing range. So this is from 0 to 639 for SX and for SY from 0 to 479. We also see the horizontal sync. So horizontal sync should be triggered from 655 to 751 when the SX is in that range. And the vertical sync should be triggered from 489 to 491 for SY. On the right, you see the code for drawing that rectangle we saw earlier. As you can see, if the position is less than 32 for both axes, we color that part of the screen in orange, otherwise everything else should be blue. Now let's take a look at the simulation and analyze the waveforms. First things first, we are looking at the horizontal sync. Here we see that each pulse took around 0.02628 milliseconds. That is approximately 38 kilohertz. So this is the time it takes the VGA to draw one line on the monitor. As we said previously, the vertical sync is fired between 656 and 751 for the range, and the draw enable must be 0 during this time. So we are not withdrawing anything. We are just telling the monitor that we are at the end of the line and CRT gun needs to move to the new position to start drawing a new line. So this was mainly used for older CRT displays, but even the current ones maintain this standard, and these blanking intervals are basically filled with other information, such as audio, for example. So let's take a look at the vertical sync now. The vertical sync is telling the monitor that we are done drawing this frame, and it's time to move on to the next one. As we can see, our time turned out to be 15.6 milliseconds, which is approximately 64 Hertz. So that's a pretty decent refresh rate, but the inconsistency here was a result of using a 25 megahertz clock. One important note to note here is that vertical sync is also fired between this 480 to 490 pixels. So this is another blanking interval, and the draw enable is 0 during this point. So this is pretty much how this VGA interface works, and now Ana will continue.
Now let's find out why we should use VGA and why we shouldn't. The advantages of VGA is that it transmits analog signals, transmits three colors, red, green, and blue. The connection of various electronic devices can happen quickly, like TVs, computers, CRT monitors. It's cheap to manufacture. However, it has some disadvantages. For example, it cannot transmit audio signals. It's not suitable for high-resolution graphics or for transferring digital signals. And the signal quality might get distorted if the pins are not correctly connected. And as it only carries analog signal, the signal quality might be also degraded at higher resolutions and longer cable lengths. As it's uncommon to still find the VGA on VGA cable and connector with today's computers, monitors, projectors, and TVs. This type of connector is being replaced by DVI, HDMI, DisplayPort cables, and connectors. And now let's see each of them. DVI, or digital visual interface, is a digital video display interface for transmitting uncompressed digital video. DVI cards allow configuration to support multiple modes with the use of different cables. Namely, DVI-A is for analog-only connections. DVI-D is for connecting digital-only connections, and this is popularly used when connecting to LCD monitors. And DVI-I is for both digital and analog connections. DVI is compatible with the VGA interfaces. It can also support analog connections. Its applications are the same as VGA. Apple even implemented mini DVI and micro DVI in its products. However, while able to support digital video, DVI, like VGA, does not support audio. HDMI, or high definition multimedia interface, is the most widely used interface. The HDMI supports both video and audio while being backward compatible with DVI. Depending on the manufacturer's implementation, HDMI can use both compressed and uncompressed digital video and audio signals, but several advanced but optional features like 3D or Ethernet data connectivity. The latest release of HDMI supports 10, 12, and 16-bit color making, and it's suitable for 4K and 8K dynamic HDR screens. Today, most monitors have HDMI as the primary display input port. We see HDMI ports on TVs, multimedia players, game consoles, projectors, and so on. What about DisplayPort? DisplayPort is a digital display interface that, much like HDMI, is capable of supporting high-resolution digital video and audio signals. While HDMI is mostly in use for various consumer devices, the implementation of DVI DisplayPort is primarily in computers. Different from HDMI, it allows the use of multiple monitors in a chain configuration. DisplayPort is the first interface to rely on packetized data transmission, which means, unlike that of HDMI, DisplayPort transmits these video and audio signals in small data packets. This feature allows for supporting high resolutions with the use of fewer pins in the port. And the DisplayPort, the latest release of DisplayPort features 77.4 gigabits maximum bandwidth. That allows it to support HDR in much higher resolutions, as well as better refresh rates and monitor resolutions above 8K. Consumer devices that use its maximum capacities are not yet around. So while VGA is still in use, they are already outdated when it comes to their output. For professional photography, video editing, or gaming, we can use DisplayPort. It's recommended over HDMI as it supports better color bit rates, much higher resolutions, and multiple monitors. VGA and DVI ports are still okay for general or office use computer monitors. Newer video cards no longer have VGA connectors, which make it difficult to use older displays. However, there are many types of converters that you can use, such as VGA to HDMI, HDMI to VGA, DisplayPort to VGA, and so on. So that's it. Thank you for your attention.